Our next topic for the AS chemistry, A-level chemistry, AS class is isomerism. What is isomerism? Phenomenon exhibited by the compounds which have same molecular formula but different structural formula. Which have same molecular formula but different structural formula. In the previous lecture we have already discussed what do you mean by the structural formula. Structural formulas are those formulas in which each carbon is treated as a single separate entity and is represented in the molecular form. For example, this is our C4H10. This is molecular formula of butane. Now, if we want to write down its structural formula, we will represent it just like this: CH3, CH2, CH2, and then CH3. That can be represented just like this. And this is the formula of N-butane. And this can also be represented just like this: CH3CH, and then CH3, and this is CH3. Which is isobutane. In this manner, the phenomenon exhibited by the compounds which have same molecular formula but different structural formula, both of these contain different structural formula. So the property exhibited by both of these is called as isomerism. Briefly, if the molecular formula is same, if the number of atoms are same, then if according to the rule, if its IUPAC name is different, then definitely both of the compounds will be the isomer of each other. But if the molecular formula is same and if the IUPAC name remains same, then those will not be the isomer of each other. Now, this is the definition of isomerism. There are two types of isomerism: structural isomerism and stereoisomerism. Now, structural isomerism further is divided into three classes. First is called as position isomerism, second is called as a functional group isomerism, and third is called as a chain isomerism. While the stereoisomerism is further divided into two classes. One is called as a cis-trans isomerism and second is called as optical isomerism. Now, I will explain all of these one by one along with the examples. The position isomerism, such type of isomerism is meant for only the functional group position. Only the functional group position. For example, if I write down, as I have mentioned both of these compounds, but remember, as there is no functional group present, that's why the isomerism present in both of these compounds will not be called as a position isomerism. This is the example of chain isomerism, because in this case, the total number of carbon atoms of stem are changed. That's why this is the example of chain isomerism, but not of position isomerism. Now, example of position isomerism is, for example, this is CH2, CH, and then CH2 and CH3. This is 1-butene. This is 1, 2, 3, and 4. This is 1-butene. But if I change the position of double bond, which is a functional group, then this will become CH double bond CH and then CH3. The name of this will become 2-butene. Now, the molecular formula is the same, but just only the position of functional group is changed. That's why this is the example of position isomerism. Similarly, if I mention here CH3, CH2 and CH2 and OH, this is propane 1-ol. This is propane 1-ol. But if I change the position of functional group CH3, CH and OH, and then CH3, definitely this will be propane 2-ol. Now the position of functional group is changed. That's why this is the example of position isomerism. Another example of position isomerism is, for example, CH3, CH2, CH2 and CH2, and then C double bond O and CH3. What is the name of this? 1, 2, 3, 4, 5 and 6. This is 2-hexanone. 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 Ketone. But I can change the position of this functional group to this. What will the formula now? Next, CH3, CH2 and then CH2 and then C double bond O, CH2 and CH3. Now, what will be the name? 3-hexanone. Molecular formula is the same, but the functional group position is changed. That's why all these are examples of position isomerism. So many examples can be given. We can also give the example with the halogenoalkanes, with alcohols, with double bond, and with all other the functional group which we have learned in the previous lecture. Now all these are the examples of position isomerism, which is mainly associated only with the position of a functional group. Now next is second type, functional group isomerism. This is the type of isomerism in which by replacing some of the atoms, the functional group is totally changed. Example, first example of functional group is, for example, this is CH3, CH2, OH. This is ethanol. This is ethanol. But if we rearrange the number of atoms, example will become just like this. This is called as dimethyl ether or ethoxymethane. Ethoxymethane. Both of these have same molecular formula but different structural formula. That's why both of these are called as isomer of one another. Both of these. Second example of such type of isomers are, for example, CH3, CH2 and C double bond OH. What is the name? This is aldehyde propanol. 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 But if I exchange the word and create some change in this compound, this will become just like this. In both of these compounds, the molecular formula is the same, but only the structural formula is changed now. But as this is a functional group of aldehyde and I have changed this into the functional group of ketone, this is the propanone. This is a propanone. This is a propanone. It means that by exchanging both of these, functional group is changed. This is example of functional group isomerism. The third example is, for example, this is CH3, C double bond OH. This is ethanoic acid. Ethanoic acid. This is ethanoic acid. But if I replace some of the atoms from it, I can create a new functional group, just like this. If I put this methyl group at this position of hydrogen and hydrogen is placed in the position of methyl group, what I will get? This will become just like this. Now, this is ester. By replacing some of the atoms in a molecule, we can convert one functional group into another. This is the carboxylic acid, but this is esters. The name of this is, IUPAC name is methyl methanoate, because one carbon atom is there. Methyl methanoate, methyl methanoate. This is the name of this compound. Now, in all of these examples, molecular formula is the same, but due to the exchange of certain atoms, we have developed a new functional group. So, all these are examples of the functional group isomerism. This is the second one. Now, the third one is chain isomerism. Now, this is the example of chain isomerism. For example, this is butanol, this is 2-methyl propane. This is butane, 2-methyl-propane. Molecular formula is the same, but structural formula is different, and only carbon atom are there. There is no functional group present, or if functional group is present, then the position of functional group should not be exchanged. The only position of the number of carbon atom present in the stem should be changed and made them as a branch. That will be called as a position isomerism. For example, if I take CH3, CH2, CH2, and then CH2 and NH2, this is my amine. How many carbon atoms are present? 1, 2, 3, 4. This is butyl amine. Now, if I exchange this in this manner, now the position of the functional group is not changed. Only the number of carbon atoms present in the stem is changed. So this will be also an example of chain isomerism. Also the example of chain isomerism. In this case, we will name this as we have already discussed. 1, 2, 3, 2-methyl and propane 1 amine. But this is butyl amine. Only the chain of carbon atom is changed. That's why this is called as a chain isomerism. All these types which we have discussed were the types of structural isomerism. Now, next is the stereoisomerism. I have explained all the concepts regarding structural isomerism. Hope you have learned all these basic concepts. Please like, share and subscribe my YouTube channel for the upcoming lectures. Thank you all.